Good afternoon, everyone. I'm Carrie Harrison with the Consumer Technology Association. Welcome to our discussion on gesture control as a part of CTA's Technology and Standards Spring Forum. We're very glad that you could join us today. The use of gesture control is enabling the freedom for individuals to command technology without touch. Gesture control was once limited to gaming applications, but is now being used in many areas, including robotics, in vehicles, XR, and retail. Last spring, CTA and its Technology Council initiated a discussion on how gesture control technology is being used, what are the opportunities for growth, and what are the barriers to adoption. I'm very excited to be joined today by three experts to share their thoughts on this topic. We'll start by sharing the speakers' remarks and discussion, which we recorded earlier. All of the speakers are live with us today and will be answering your questions after the panel discussion. To submit your question to our speakers, click the icon with the speech bubble in the toolbar at the bottom of your screen. Feel free to submit your questions at any time. And with that, let's get started. Our first speaker is John Underkoffler. Welcome, John. Please introduce yourself, your company, and your role in the space.
Thanks, Carrie. Delighted to be here. Excited to get into a little discussion with my august co-panelists. I'm John Underkoffler. I'm the founder of Oblong Industries, a 15-year-old company whose origins really have entirely to do with gestural interface, spatial UI, and a host of related concerns. Part of the strange part, a strange part of the origin story, if you will, of Oblong is that earlier I had served as the science and technology advisor to the film Minority Report for Steven Spielberg in 2001, although the film came out in 2002. And in fact, the gestural interface system that I designed for that film, for the Tom Cruise character and other actors to use, does play a very active role in the development of the ideas and the technologies that Oblong is currently purveying today. So why don't we get right into the presentation proper? And although, of course, it's certainly the case that everyone in today's panel, I assume, is enthusiastic about gestural interface, gesture I/O, I'd like to take a slightly different tack, which is to say, namely, that if you embrace the idea of gestural interface, and if you follow it authentically and honestly, and build out in the directions that it leads you, you end up with a much larger set of technologies, philosophies, and really approach to user interface and to computation and technology in general than gesture itself alone might suggest. So with that as the kind of wrapper around the entire few minutes of this talk, let's take a look at some of the lessons that I've uncovered in the last 25 years of this work. So to begin with, I think it's useful to think about human hands. Hands are unique, perhaps, among human sensory apparatus in the sense that it's not just input, but output as well. Your eyes, of course, are critical to living in a spatial world, a visual world, a world where navigation and understanding of the spatial components around you is very important. But hands not only understand the world by touching, by the sense of touch, but they also manipulate it. And so, in a sense, the hand is a powerful locus of full closed-loop understanding. And it's that we want to focus on, self-evidently, since we're talking about gesture. The story for me begins at the MIT Media Lab in the late 80s and early 90s, where I was convinced that, it was 1994 when I really started this work. And I thought, well, the UI as we've known it, the Macintosh UI, the desktop metaphor, the overlapping windows and clicky buttons and pull-down menus and the rest of that, driven by a mouse and keyboard, that's nice. But 10 years, surely, that's a long enough run for any one UI. What should be next? Now, that point of view was a little bit naive, obviously, since we're here still 35 years later, stuck with the mouse and keyboard. But my idea was, what could we do that makes better use of the incredible manipulatory capabilities of the hand? What if we focus on the hand? And what if we, for the first time, take the output and input of the operating system, the UI, if you will, and co-locate them? You can think about what happens when you use a mouse. Your hand is somewhere down on the table or a mouse pad, but what you're interested in is on the screen. So we've kind of separated them. What if we put them back together? And the result was a system that we called the luminous room. And the basic premise was that we equipped users, we equipped pilots of this new kind of user interface with a set of physical icons, in a sense, that represent in a very direct and almost literal way elements of a simulation or elements of a domain-specific inquiry. So here you have a building, a bit of architecture. You've got an inverse clock that lets you swing the sun around in the sky and explore shadowing effects at different times of day. And what happens when you build a UI that has conformed input and output like this, that gives full manipulatory access to human hands, is that you end up with a sense, you end up with a very powerful kind of causality. So to explore the effect of small changes in angle of the position and orientation of the building on glare, as we just saw, as the sun progresses throughout the day, you simply reach out your hand and rotate the building, which is a manipulation that we understand innately and that we've all been experts at since we were, 2 years old, probably less. So that kind of direct I/O causality where the world is there, you reach out, you affect the world, and you observe the result of the effect is incredibly powerful. One of the big lessons from this is that we need a non-abstract graphical system. You need what we call real-world pixels. That is to say, the pixels literally exist in the world of that simulation. And instead of saying, turn on, the upper left pixel, which normally would be called 0,0, you turn on the pixels at some particular X, Y, and Z location. Every pixel in the room, every location in the room has a unique address, a unique name, which is its literal location. And you suddenly have this incredible conformed I/O system. The next step for me was Minority Report, and it's one of those accidents that actually only happens in real life. It's weirder than fiction. I ended up getting swept into the kind of Hollywood vortex and came aboard Minority Report as the science and technology advisor. And although I was responsible for all of the tech, the future tech that was to be depicted in the film, set in Washington, D.C. in a future 2054, it was in particular the IT systems, the pre-forensic analysis systems that the characters would use that I spent a lot of my time on, because it was literally a continuation of the work I'd been doing at MIT. We knew that these crack detectives, these super SWAT team detectives, would need to be seeing an array of images pulled from the dreams of the slumbering precogs as they dreamt about future violent crimes. The question was, how do you interact with such a system that's physically large, that has multiple, a manifold of different images and elements? And the answer was gesturally, without the intermediaries of the physical icons that we saw in the previous example. And so I built out of pieces of American Sign Language and International Sign Language, SWAT team commands, ground air traffic control commands, all of the gestural systems that human beings have developed for the real world, a domain-specific gestural language for the actors to use. We spent weeks training the actors, and so although at the end of the day what was seen on screen was composited in, that is to say the actors weren't actually looking at pixels on the screen, the actors really were using this first sophisticated gestural system. And let's take a brief look at what that looks like now.
See if I can capture that.
Running out of time. I was thinking maybe I'd play hooky, stay home today.
Right, meeting.
Working too much.
Can you grab that? So clear.
Very slow.
Blind the hand without them.
Got him in the Foxhole. 4421 Gainsborough.
So we've got actors imagining what they're going to see on the screen. They've been trained extensively, so they know what they're going to see on the screen, and they're actors, so they can use the world of make-believe. But because of the training, because there was real causality involved, in other words, Spielberg would say, okay, in this scene, we want Tom looking out the window. He's going to see an architectural detail that clues him in on what part of town the crime is going to happen in, and he needs to pull that over and run a kind of architectural analysis on it. We could translate that effectively in real time into a sequence of commands, the language that the actors already knew. And what came out the other end was something of very high level of, I think, verisimilitude. It looked like the real thing because the actors really were doing the real thing. That takes us to the third part of our journey and the third part of the learnings, which is oblong industries. And in fact, reactions to Minority Report were so enthusiastic that at a certain point I realized I'd somewhat inadvertently conducted the world's larger user focus group test around gesture technology and shown people this is what the future could look like. This is what UI could look like. Is it interesting? And the resounding answer seemed to have been yes. So I and a few others put together Oblong to turn that kind of fictional UI into a real world UI. First thing we did was to build the gloves. This was a literal recreation in some sense of what was seen on the screen in the film. And let's take a brief look at some of the stuff that we built in those early days. This is an overview of G-Speak, which is what we call our Minority Report operating system, if you will. And right away, you see the idea of pointing. Pointing is an incredibly powerful human gesture. It's a geometric gesture, a spatial gesture. It connects your body to distant stuff. And by wiring it up to a UI, you get something that people already know. They innately know how to point. We know that from the time we're born, more or less. At the time we can control our limbs, I guess, which is a few months in. You point at things you want. You point at things you're indicating. But we put efficacy on the end of your pointing. So for the first time, you can point at something. Of course, you've always been able to do that. But when you point at it, you can now pick it up. You can grab it. You can move it around. You can navigate. And so pointing, I would nominate as the single most powerful and central gesture that needs to be implemented in any gestural UI system. The second is what we're looking at right now, which is effectively the idea of navigation. Your hand, a single human hand, it turns out, is capable of full 6 degrees of freedom navigation, which is quite a feat. You can't do that with any other UI system. And so that becomes very powerful. The combination of visualization and navigation leads to a new kind of cognitive understanding and new kinds of cognitive opportunities around a bigger pipe between the computer and the human mind. A full loop, closed loop system that lets you fly to what you want to see, lets you manipulate once you get there, and lets you ask and answer the questions in the most natural and kind of innate system that we have as humans, which is causal interaction with a spatial world. So I'm going to cut that video short and move on. So there are several lessons that come out of it. When you start building these systems, of course, you've got large arrays of pixels. And when you start driving enough pixels, you realize that you're driving more pixels than a single computer or a single video card can possibly handle, which means you're starting to build systems that span multiple video cards, that span multiple computers, multiple compute units. And while you're at it, you may as well make it so that you can span multiple operating systems. And that this leads to a new kind of computational design, computational architecture, which we can think of as spatially distributed computing. We need multiple systems, maybe even multiple OSs, to conspire together to give you a single, spatially conformed, seamless user interface experience, which this next video shows in miniature. So what you're looking at here is a tiny little bit of media, a thumbnail of a fresco, swimming around 5 different screens that are being driven by 3 different computers and 2 different operating systems. And what's interesting is that the experience that the user, the operator, receives doesn't know and doesn't need to care about any of those technical details. Instead, what she or he gets is a single continuous interaction space, irrespective of the fact that it's being driven by a bewildering array of different technologies. And that's critical. We need to build systems that work in precisely that way. We need to decouple the idea of the UI from individual devices. When you're using a tablet, the UI literally has to end at the edge of the tablet because there's no more pixels there. There's no more touch there. By decoupling the two ideas, which is a very easy thing to do in principle, but requires some work in practice, you end up with a much more resilient, scalable, and ultimately powerful display. The next lesson is that it doesn't have to be bare hands or even gloved hands. Sometimes it's actually valuable to have something to hold on to. And at Oblong, we've built a series of what we call spatial wands. This is a more recent vintage that is an optically mediated wand. The particular technology is important but doesn't matter. In this case, what's important is that by using a wand, first off, you can pick it up and put it down. You can't take off your hand and put it down. So there's a cue both to yourself and to people who may be in the room with you when you pick up the wand that something's about to happen. And those social cues, if you will, are actually very important. It turns out to be a lot easier to get people to pick up wands than it is to get them to put on gloves. And the idea that it's just a remote controller, it's like a laser pointer, except a laser pointer where you can pick stuff up at the end of your pointing, is incredibly powerful. The third idea is that gesture encourages us to work at scale, which is a really important idea. You don't need gesture, frankly, if you're using a laptop. Your hands are right there. You can type on the keyboard. You can use the mouse. There aren't really enough pixels, so there isn't enough information, and there isn't enough space to warrant the use of gesture. However, there is a large category of problems and problem spaces that demand more pixels, that demand more seeing. Because when you can see more, you can understand more, and when you can understand more, you can do more. And so part of the philosophy at Oblong is be big when you need to see and understand more stuff. This is an image of the large-scale prototyping facility at our warehouse in downtown Los Angeles. You see on the left an immersion room, which is 5 of the 6 sides of a hexagonal space. And more distantly there on the right side, you see an enormous 40-foot pixel wall. And when you have that many pixels, you don't want to be standing up right at the pixels, touching them. You literally can't see enough when you do that. You need to step back so you can see and apprehend everything. And then you need a system that can get at all of that stuff. And again, gestural pointing is the answer. So here is a video that shows very, very briefly what that can look like. This is a visualization of 6 hours in the embryological development of a quail heart, which has certain wacky properties as the cells swim around during the early morphological assembly that is of intense interest to people who are intensely interested in that sort of thing. But what I think you can see here is that by using a wand or gestural control, you have the opportunity to navigate in a way that's deeply meaningful and cognitively dense. You can take any piece of the information, swim into it, pull it around you so that you can inspect a micro piece of it, push it back so that you can see the macro, rotate it around. And here you can see we can interrogate the time series as cells begin and end their journey into the formation of the final heart and so forth. This is just a small example, a couple of weeks of work in collaboration with some folks at USC and elsewhere. But the idea is, whereas the application domain is not universal, the idea is navigation and pointing, lots of pixels, lots of understanding, all under gestural or spatial control is kind of critical to the work that increasingly the world needs to do, whether it's epidemiological, which is kind of important right now, or whether it's supply chain, whatever it is that we're going to use to get us through the 21st century is complex. It's more complex than ever before. And frankly, just sitting at a laptop with a small number of pixels doesn't cut it. So we will jump back here to these slides, and I'm going to skip the final video. But another learning along the way is that when you've stepped back from a large number of pixels, de facto, all of a sudden there's room for collaboration. There's room for a second and a third and a fourth person. And the act of collaborative seeing and the act of collaborative control is something that's familiar from the everyday physical world. It's only these little beasties, computers, that over the last 35 years have turned us into these weird solipsists that make us alone because the UI only knows about you. And so collaborative interaction is the critical idea. So to summarize, what we find is that when you start with gesture, you follow where gesture leads, you follow where the hands lead, you end up with a much bigger set of propositions than gesture itself at first blush suggests. You end up with systems that are multi-everything, that can be multi-screen, that can stand astride multiple machines, multiple OSs, multiple surfaces, not just a single wall, but systems that can turn corners. Multi-user, systems that are collaborative, of course. Multimodal, it doesn't just have to be gesture. We'll probably talk about that more during the Q&A. Gesture is one piece. There's still room for the mouse and keyboard. Multi-device, we live in a heterogeneous world. We have to be able to interoperate between devices. The age of silos will kill us if we adhere to it much longer. We need everything to talk to everyone, just as we need every people to talk to every other people on the planet. Multi-stream and so forth. And these are systems, of course, that are spatial and temporal, computing systems that understand space and time, the two most important physical measurements or physical characteristics of the universe, which every computer programming language and every UI system to date has effectively ignored. Let's unignore it. Systems that are gestural, which is a great way of getting at spatial and temporal stuff, and systems that are distributed and collaborative and concurrent. And more than anything, systems that properly and respectfully treat both the hands and human eyes, where not only love goes in, but of course all of the understanding of the world goes in. So that's what I've got for today. Thanks for your attention.
Great, thanks, John. I think I'm going to have to add Minority Report now to my quarantine watch list and look at it through a new set of eyes here. So I'd like to now welcome our next speaker, Matt Carell. So welcome, Matt. Please introduce yourself, your company, and your role in this space.
All right, well, thank you very much for having me here today, guys. My name is Matt Carell. I'm the design director for a company called Ultraleap. I'm going to tell you a little bit about me, a little bit about what Ultraleap does, and then I'm going to dig into some of the details of a couple of our use cases so we can talk about the kind of gestures that me and my team design with. Just briefly on me, I've been working as a designer in one form or another for about 18 years. I actually studied product design originally, began as a toy designer for Lego, going way back. So working as a product designer, I was in a lot of agencies commercializing new technology for a lot of years. So medical devices and smart energy meters and things like that. And I began to work a lot more with larger companies to help them around creating breakthrough new products and building a culture of innovation and design in there. So I did that for the likes of Sony and Coca-Cola. And I transitioned over into the digital interaction stuff about 10 years ago, worked for a renewable energy firm, did some virtual reality work. And the last few years, I've been working with a lot of startups in fintech and cryptocurrency, things like that. So I developed sort of a specialism in more complex or bespoke user interfaces for professionals. I'm now working for Ultraleap. So Ultraleap is a place where I get to use all of those specialties. I'm doing quite tricky interaction design. I'm humanizing new technologies. And I'm helping the company to build more of a culture of design and innovation. Ultraleap does two main things. We've got these two core technologies that we're bringing to market. On the left-hand side is the Leap Motion camera, which delivers what we believe to be pretty much world-class hand tracking. So a full skeletal model of the joints and the fingers. And this enables you to do the gesture control for a huge range of devices. Meanwhile, over on the right, what we call mid-air haptics. So we use ultrasound to create a sense of touch in mid-air. You think of it as something like a force field-like sensation. You get a slight resistance against your finger or your palm, and we can control that with enough accuracy to deliver small shapes and animations and pulses up to your hand. So when you combine these two technologies, you've got the potential to not only push a virtual button in space, but actually feel something back in your hand. So that's really exciting potential, especially for a designer, but there's no universal rule book yet for how you do this kind of spatial interaction well. And our job is to try and figure this stuff out. Now, Ultraleap is working with a very wide range of customers in a lot of different industries, a lot of applications. And I'll put up a few examples for you today. We're doing a lot of work in the automotive industry. So up there in the top left is a concept car we did with DS this year. And here we're really looking at car HMIs, so controlling music, navigation, and that kind of thing just through gesture control in the car. In the center there, some of the examples of public displays and kiosks. So we're talking about 2D screens, and we might be talking about retail displays, ATMs, fast food, ticket ordering, that kind of thing. Now with COVID-19, we've seen a real surge of interest in making these kind of displays touchless. So we have a lot of customers now asking us to look into how we can apply our technology in these different situations. And then over on the right-hand side, some of our enterprise VR applications. So the Leap Motion camera has been being used by a lot of companies out there in the VR world for a few years, the likes of Autodesk and Gravity Sketch. And they're using it to do design reviews of cars or architecture, explore remote collaboration and ergonomic assessments, things like that. We get used in flight simulators. We get used in live music performance, even in music production in the studio. And then finally in interactive art installations and things like that. So I lead the experience design and research team at Ultraleap. We're a group of user researchers and interaction designers. And our job is to help all of these customers to try and implement gesture control and haptics in the most natural and intuitive manner that we can. Like I said, there's no rule book set for this yet, but we're trying to write it. And we're doing that through a combination of user research, interaction design, prototyping, and user testing. So I want to dive into a couple of examples so that I can get into the details and talk about a few of the gestures that we're typically working with. So for 2D displays like this, that you might get in public, this is a pretty typical hardware setup for us. The camera and the haptics unit with our technology are embedded in that black box you see there. And that's a product called the Stratos Inspire that we make. And we used this setup last year for quite an in-depth study into interactive movie posters. So we were rolling these things out in cinemas in the US. Our user research team was there observing how the public interacted with them. And we learned a ton of stuff about what happens when you plant this technology in the real world. All these things we wouldn't have considered back in the lab. So stuff like on approach, these products that you control through gesture need to communicate that they're interactive. It's not just a poster. Then it needs to communicate that it's not a touchscreen, that actually you don't jab the glass, but you need to stand back a little bit and you need to hold your hand out, hover it over the unit we make there. So we want to get people up to it, putting their hand in the interaction zone where we can deliver haptics. And if there are gestures, we might have to teach them those as well. So there's a ton of information that you have to get across to somebody before they can be in the experience enjoying it. And we found ourselves having to look into the industrial design of the unit, graphic signage in different areas, on-screen animated prompts, and all these small, subtle things to try and say, come over to me, I am gesture controlled, you know, there is something for you to try here. So it goes beyond the gestures there for us for consideration of the product as a whole. So when I get into the gestures, we have a small library of things that we typically use, and it varies from use case to use case. On 2D screens like this, to start with, we have a choice of ways to we can control something like a cursor. And these are a couple of commonly used examples for us. On the left touchscreen style, this is you holding out your hand, palm down. You could be pointing with an index finger, you could be pointing with all your fingers. And you move your hand around the screen to the object you want to interact with. Much like you would on a touchscreen, you're just not going all the way to pressing the glass. On the right, the pointer method. Here, rather than moving your hand, you keep it more or less in a comfortable position and you angle your fingers around. So we can track your fingers and project a cursor from there off to the screen. And the reason to choose between them is chiefly ergonomic. The touchscreen style is very intuitive. It's something that people are familiar with in a sense already. And it works very well on a small screen where you can comfortably reach everything. But for some users, particularly if the screen gets bigger, we might be asking them to reach uncomfortably, or some users might not be able to reach the whole display space. So there we need another method, and that's where the pointer method works a bit better. It lets us use a larger interaction area. The other advantage for us, of course, is that if we have the hand down in a comfortable area, we can still deliver haptics, etc. So we've got to weigh up the pros and cons of each in each use case. Then even when we get into the interactions, you know, we've got a choice of ways that you can press a button. The forward to select method over on the side, this is about moving your hand a little bit forward till you get to the point in the air where we're going to register you're pressing the button. So that's like using a touchscreen, but just not going all the way to the glass. Now that's very natural for people to point towards something, but suddenly we're asking them to go from a point in space to another point in space. And they need some feedback. So we find that we need to give them something, and we've had a lot of success with a sort of visual reticule on the screen. Concentric circle that gets smaller as you get closer to the right point. Even better if we deliver a haptic pulse to your hand when it's time to press the button. Alternatively, something like pinch and select, well here we don't move our hand, but instead we change, and we change to another gesture. We have a whole library of them, but a very common one is this kind of OK pinch gesture. Now, the reason we do that is that gestures are analog. It's not like pressing a mouse button where it's on or off. People move their hands through a whole range of motion as they shift from a gesture to another. Couple that with the fact that everyone's hands are different, everyone does these things differently, and it can be quite tricky to be certain you've understood user intent. Did they mean to press that button, or were they just trying to scratch their nose or something? So something like the pinch gesture is very distinct, and we can be very sure that if somebody does that, they meant to press that button. But because it's distinct, well, this isn't really something you do naturally when you think about pressing a button on a screen. So we have to teach people that we want them to do this, and we've got a barrier to use there. One of these is maybe a little more intuitive, one of them a little more reliable. So we often use the pinch in situations like car HMIs, where safety is more important, and people might be able to invest a bit more time in learning. The forward to select we use more in public kiosks, where something like speed and immediacy are more important. But it's not as clear cut as this gesture does this job. We have to weigh up the pros and cons of each. And I want to get across also that these gestures don't exist in isolation. Forward to select there will not work without that visual feedback from the UI or the haptic pulse. So at Ultraleap, we talk about interactions, and there we're wrapping up a gesture, a visual UI component, a haptic, maybe even a bit of audio to make an interaction that works well. Now it can change again when we get into VR. So I just talked about how the pinch could be a little bit odd if you're standing in front of a screen trying to order a sandwich or something. But if you think about using that gesture in real life, you typically do it to do things like pick up a small object, pull a string, or push something. And so when we get into designing for XR, we lean on that and things can make a little more sense. Excuse me. So we do things like grabbing an orb to move a slider, picking up an object to reposition it in space, even using two hands and pinching at the corners to grow or shrink something. Our goal is always to find the most natural and immediate interactions we can. And in UI, when the UI is in VR, we can lean on those kind of physical elements so that something like the pinch actually makes a bit more sense. When we're building these applications and we're building in gestures and assigning them to functionality, I'm starting to find that we really only use a very small number of gestures per application. And in my experience, it's often between 1 and 3. There are two main reasons for that. One is that users won't recall a whole series of gestures, at least not without a lot of practice and time invested. It's all new, there's a lot of stuff to remember. But even if they could remember a lot, we may not be able to distinguish reliably between them. So you remember what I said about the pinch. The more gestures that we cram into a given application, the less distinct each one is, and the more chance there is that we'll misunderstand somebody's intent. So we have to think very carefully about the most frequently used functions. And we have to ask, what does somebody need easy access to, and assign that to certain gestures. But in something like Enterprise VR, there might be a lot of functions, so they've got to go somewhere. And we end up having to get into things like this, menus and toolbars or switching things within context. So typically we might do something like the menu on the left, where we turn our hand over to bring up the main menu to allow us to switch function. It's reasonably comfortable if you're not doing it a lot, it's reasonably distinct. And we find that users tend to think of one hand as the menu hand and the other as the action hand, so it works quite well. Or we might do something like on the right, where we embed toolbars and menus into the environment, or we try to switch them depending on the context of what you're doing. The key thing for me here is we have a small number of gestures to play with. So if we're going to offer full functionality for something like a VR application, we also need to consider the environment and UI elements together. So to kind of wrap up some of the key points that I find when we're designing this stuff. Firstly, that gesture control is new to people, and most people haven't tried it out. They don't know paradigms or how you're supposed to work with it. So when we put devices out there that are gesture controlled, they need to convey their use to people, especially in a public space where somebody's just going to walk up and try and use something straight away. So we have to start thinking about the industrial design of it and the semantics of it for that to work. Gestures aren't universal, at least that's what we're finding so far. Each time we work on a project, the choice of gesture is affected by the hardware, the ergonomics, and the use case. And what works for a public kiosk with a 2D screen is different to what works for VR and different to what works, again, in a car HMI. We can use only a few gestures each time, again, because of that need for them to be distinct and for us to be certain about user intent. So we have to think carefully and map only the most important functions to them. And our choice of gestures for those functions does sometimes mean balancing intuitive versus reliable, and finding the right compromise for the situation. The other functions that we might want to use, well, we can't necessarily use a gesture for each one, so they need to be accessed elsewhere. And particularly in things like VR, that means considering the UI or how else you can access that stuff. And finally, that we design interactions, we think. So the gestures themselves are often need to be wrapped up with a visual UI element, with some audio, or with some haptics if our product's being used there. And when we tie them all together, we get some more successful interactions. So that's it from me. Thank you very much, and I look forward to some questions later on.
Great. Thanks, Matt. And now we're going to hear from our third and final speaker of this afternoon, Glenn DeVos. Welcome, Glenn. Please introduce yourself, your company, and your role in this space.
Good afternoon. My name is Glenn DeVos. I'm the CTO for Aptiv, and I've been in the automotive space for about 30 years now. And it's great to be here today to share a little bit about how gesture fits into our overall human-machine interface strategy for controls of the vehicle. So as we think about what's happened in our space and the evolution of gesture control, we've really seen it go from research to media, entering entertainment, and now into consumer products. And in 2015, we actually introduced gesture control for the first time as part of the automotive cockpit with BMW. And really the driving force for that was complexity and safety. And what I mean by that is when you think about how the automotive cockpit has evolved over the past century, from the early 1900s, where it was a simple mechanical interface, and you essentially had a minimal number of controls, all physical. And then over time, with each passing decade, more and more controls, more and more information being displayed to the driver and to the occupants of the vehicle. And then in the 80s, more and more electronics. And as that trend has continued, really what we've seen is the amount of information and the amount of surfaces and controls that are presented to the driver has continued to grow. And more recently, since 2010, the digital aspect of that information. So what you see today in a cockpit in 2020 is typically 2 full screens, maybe even 3, with a large array of both physical as well as digital content being provided to the driver. And what that complexity means is that you really have to think about how do you interact safely with that ever increasingly complex environment? How do you avoid the situation where you're really creating a distraction for that driver? And it really is a challenge. And that's one of the things that we looked at, recognizing this trend, and explored, well, how can gesture help us do that? And as you project out, if you think about the cockpits of the future, really, we don't see that increase in content and complexity diminishing. More and more of that content will be delivered digitally through reconfigurable displays. But again, more information is coming at the driver. And really, that challenge, again, is how do we make sure that the driver can interact safely with the vehicle? And that was really the motivation behind our work in gesture controls. As we think about the future, though, it really opens up a lot of new dimensions for us. Think about level 3 or level 4 automation. You can have reconfigurable interiors, flexible seating, interactive gaming and entertaining, just to name a few of the options that are available to us. And that just opens up tremendous applications for touchless interaction, augmented or virtual reality applications, as well as new interior designs and making them more personal and more personalized for the occupants. So a really exciting period ahead for us. And we see gesture as playing an important part of that overall landscape. In the next video, I'll show you how we actually applied gesture to the BMW Model 7 program. This was our first introduction in 2017. And essentially, it's now been launched on over 13 different models for BMW with a very, very high penetration rate. So we're really excited about this first step and looking to build on top of it.
The all-new BMW 7 Series comes with a new interface design, which makes it easier to operate the car. Use touch, gesture, speech, or the iDrive controller. whatever suits you best in a driving situation.
A never-seen-before feature. You can operate the system via simple hand gestures, so you can keep your eyes on the road. There are 4 predefined gestures and an additional 5th one for customizing. Take a phone call or decline it. Raise the volume or lower it.
This gesture is the customized gesture, to which you may assign a function of your choice. So no more pushing buttons from now.
As you can see in the video, gesture works as part of a multimodal HMI. So it's not just gesture by itself, it's gesture working in conjunction with the driver's eyes, the driver's use of physical interface controls, as well as voice commands. It's really part of a complete solution. But how does gesture work in the vehicle today? So really there's just several key components. The first is in the roof module of the vehicle, you have infrared LEDs that are basically illuminating a zone of the car. In this case, it's directly above the center console. So about where your right hand would be for a left-hand drive. In addition, you have a camera also mounted in the overhead control that is now looking at that zone and watching what your hand is doing. So as your hand basically gestures in certain predefined ways, the camera detects that, and it also detects motion or essentially depth using time-of-flight technology. So it can see in 3 dimensions how your hand is moving, and then interprets those gestures to basically compare against a predefined set of menus that, in essence, close the loop or determine what action the car should take. And that can be done simply as a standalone gesture or as a gesture that works in combination with a voice control. So let's look a little bit more about what gestures we've already launched. So these are some very basic gestures. And one of the things I would say is, and the challenges we had in really implementing gestures, when this program first started, everybody had a very long list of all the possible gestures that you could use in a vehicle. The problem is, a gesture, for it to really work, it has to work every time, all the time, over all the different use cases, lighting situations, a reflective coffee cup being beneath the person's hand, every scenario that you can imagine. Additionally, it has to work for every size of hand, every type of hand, nail polish, you name it, every possible configuration you can think of. And it has to work around the world. So it has to be fairly universal. So as you start looking at all of those different combinations, you realize we really needed to start with a very basic list and very straightforward gestures as a starting point. And so you can see here, there's a swipe gesture, which is very intuitive, which essentially means decline or negate a prompt. So it's basically saying no. You have the pointing gesture, which I think, again, very intuitive, one that we're all familiar with, which you can use to either select or confirm a prompt. So again, working with voice commands, not just simply stand alone. And then 2 fingers not moving is a configurable. It has a default of pause or play, or it's a self-configuration. So you can teach that to be something that you want it to be. It's a personalization option. Additionally, we have a couple gestures that can control volume or can control other positions, for instance, next song. And those are done with finger spin, either clockwise or counterclockwise. And here's where that 3D aspect becomes important, because you have to be able to tell that the user is actually moving their hand in a circular motion. Now, as simple as that sounds, well, how circular is circular? Is an oblong circular, or is it very tight? So those are all the things that you have to basically train the system to understand and to interpret, because there's nothing more frustrating than trying to operate a system using gesture when it doesn't react the right way. And then similarly, when you're making a selection of a next song or you're selecting something, we use essentially a circle or a pinching movement that you close your thumb and your index finger and then can move that left or to the right to indicate the desired action. Everybody makes that circle a little bit differently. So how do you train the algorithms to be able to interpret when you make a circle like this? It has the tolerance to be able to accommodate all of those variations. So we launched this in 2016, and I would say that we've learned a lot along the way. Just like any new HMI technology, there's always things that you anticipate and things that you learn from or adjust, and that's been the case here as well. But what we have actually validated is, as the users become experienced with this, it does allow the drivers to keep their hands on, basically hand on the wheel, their eyes on the road, and essentially maintain a greater degree of focus on the driving task. So from a safety standpoint, it's achieving our objectives. The other thing it allows us to do in terms of layout of the cockpit is, with the use of gesture, you can have more flexibility in where you can position screens and control surfaces. And that's very important relative to how you want to lay out that cockpit for visibility and ergonomics. And you can eliminate some of the buttons, which is always good from a cost and complexity reduction standpoint. But we've also recognized that there's many new opportunities ahead for us in terms of, well, what can we do if we combine gestures with situational awareness of where the vehicle is and also knowing where the driver's eyes are looking? So suddenly we can start using multimodal HMI concepts to augment the services and really provide kind of new and exciting features for the driver. So when we think about what comes next, I'll show you a video that illustrates this point of how gesture can be integrated as part of a full multimodal experience, not just in terms of HMI, but also in terms of interacting with the vehicle and the vehicle environment. And this is truly exciting.
Natural human interaction takes place through a combination of speech, gestures, and eye movements. How will we interact with our vehicle in the future? The vision, natural interaction with the vehicle, the same as with a passenger. BMW sensors register customer behavior in a number of ways. BMW enables a whole new way of cockpit interaction.
Hey, BMW, what's that?
That is the intelligent safety function. Would you like to know more about it?
Yes. What kind of restaurant is that?
New technologies also make it possible to directly interact with the vehicle environment.
That is the Mediterranean restaurant Don Camillo. It has a 4 out of 5-star rating.
Do they have a table available tonight?
There is a table for 2 available at 7 p.m. Shall I make a reservation?
Yes.
By intelligently linking gesture, speech, and eye movement monitoring,
Park there.
BMW revolutionizes the interaction with the vehicle.
So when you think about those systems, what does Aptiv provide? So what is it that we work on and my team works on? Well, first of all, it's the AI-based gesture recognition and the in-cabin sensing software. So those are vision algorithms combined with AI to train the systems to learn how to accommodate and how to interpret all of those hand gestures. And that's where we spent the bulk of our time, along with testing in every possible environment. One of the first things we realized is, as you're driving, the lighting conditions are constantly changing. And as those lighting conditions change, you need to be able to adjust and accommodate them. The second is we integrate that software as part of a full system solution. So we combine it with everything else that has to operate essentially in the vehicle, including the in-cabin sensing systems, the other HMI systems. So it has to be integrated as a full solution into that vehicle. And then we provide the hardware, the in-cabin sensors, the compute platforms, all of the things that make that work, the roof module in which those cameras and those sensors are located. And then put that all together for the OEM and validate that so that it operates flawlessly over all of the vehicle use cases. So all of the environments from the very hot to the very cold. And that's also, that proved to be quite a challenge because things like gloves, suddenly now you have to figure out how do you recognize gloves or other mittens and things that obviously make gesture recognition a little bit harder. But as we think about gesture, we have a good foundation to build on, and we think, beyond gesture. Right now, those applications are limited to what we would call premium vehicles. If you think about the BMW 7 Series, that's a premium vehicle. And we really want to see gesture deployed across all vehicles and really democratized as part of an integrated HMI solution. Something that really helps us do that, obviously, is volume, or being able to combine gesture with other sensing systems. And what's exciting here is that for Euro NCAP and other safety agency initiatives, child presence detection, driver readiness or driver state sensing, seat occupants classification, we're putting more sensors into the vehicle that will enable us to actually deploy gesture in a much broader way at a much lower cost. Because the same sensors that we're using for some of these features, as I mentioned, driver state sensing and readiness detection, we can also use for gesture-based systems and gesture-based controls and interaction. So we know as we deploy more sensing into the cabin, and as we do that across a much broader array of vehicles, it provides a really exciting opportunity for us to use gesture in a much richer and a much broader way. Thank you very much.
Great. Thanks, Glenn. And thanks to all of our speakers for being here with us today. I know I've just learned so much and I've been jotting down questions furiously, but we're definitely going to save some time here for our audience. So if you have not submitted your question, please feel free to do so now. But I wanted to start with a question here for all of our panelists. So obviously we're not all in the same place right now. The COVID-19 crisis has led us all to be learning some new things, which has made me think a little bit more about the use of gesture control since it's touchless technology. So I'd love to get your guys' opinion on how or if you believe this COVID-19 situation might help accelerate the use of gesture technology. So Glenn, do you want to maybe jump in first?
Sure. I think it clearly will have an impact on our environment. And for the automotive space, that's everything from how we build cars, quite frankly, and how we assemble cars and manufacture them, all the way to how we use them, how they're sold, and how they're maintained. So we know it's going to have a significant impact on us. Now, as you mentioned, gesture is touchless. So suddenly, touchless becomes a true asset. And so when we think about shared mobility, when we think about level 3 or level 4 cars that could potentially be used as part of a mobility service, that certainly opens up a number of opportunities where people will want to be able to provide controls, interact with the vehicle around them, but doing so in a touchless manner. And gesture becomes the primary modality for enabling us to do that. So that for us, we think really offers up some interesting opportunities.
Matt or John, any thoughts from you?
And I'd say we've certainly seen a real surge of interest from a lot of customers, and chiefly, I suppose, a lot in public spaces. So where there might be a touchscreen device in a public space, kiosks and ticket machines and things like that. Even in some cases, elevators and mechanical devices. We've had customers say, we think that our customers may be concerned and we want to know what it might take to integrate this new technology. So on one hand, we've been doing a bit of user research to go out there and check these assumptions and learn about customer attitudes and kind of indicating that, yeah, that's probably true. Now we're trying to figure out where we think that this concern might be strongest. But as we look into it, one of our biggest concerns now is what would it take to go out to existing machines in the world and retrofit them? Yeah. Some of these things out there have got older processors or they're in particular environments and it may not be ideal. So, we're having to look into what it would take to implement our technology in all these different places in the world without it having to cost a fortune or mean scrapping what's there.
Thanks. John, anything you want to add?
I certainly agree with Glenn and Matt. One of the deepest grievances that I have about technology today and user interface in particular is that it's been kind of an open loop system. The development of this stuff has been an almost pure consequence of a sort of commercial juggernaut that doesn't really take inputs from the real world. And I was about to say, one of the great things about the pandemic, there's nothing great about the pandemic, but the opportunity that the pandemic is putting before us, and it's kind of up to us whether we take it or not, is to rethink everything, a global level rethink. What technologies are useful? Why are they useful? What is the job of a user interface? Who does it serve? Does it serve the person collecting information about you so it can advertise to you? Or does it serve you? All of those questions, as I said, have the opportunity to be asked and answered now. And obviously, while we're all stuck in our homes, the issue of touchless gestural control is less relevant. But once we sort of get back out into physical society, into the world around us, I think we're going to think really, really differently about contact. Among many other things, we'll think differently about. So gestural UI may well get the boost that it has long deserved, and is probably also technically and in terms of our design skills ready to step up to.
That's great, thanks. So that kind of gets me thinking a little bit about the consumer. And as I mentioned, CTA last fall had a discussion on this topic, and I wanted to get your guys' thoughts on what the consumer education barrier might be for implementing gestures. So if you would need, for example, a different set of gestures to maybe operate the ATM versus turn on your car versus play in a game, is there a consumer education barrier that we need to be thinking about? And which one of our panelists, I see you all nodding, want to jump in and start us off? Matt, maybe would you like to?
I mean, I think there is absolutely, though, of course, it's, it's not about just teaching them what it is we think it should be. There's a bit of give and take here about, we're trying to design something that's absolutely as intuitive as it can possibly be. But there's a flip side where this is a new way of interacting. There's going to be new stuff. And as I talked about in my talk, sometimes I'm forced to choose between a gesture that might be the most reliable, but it's not necessarily the one people would think of first. So I think it's definitely there. And I think from what we've learned about rolling out displays in like our study in cinemas, etc., all that stuff about industrial design and communication from a distance, what is this thing? And even recognizing what this machine is, and then I'm supposed to go up and wave my hand in front of it. That's totally new. So I definitely think there are concerns there beyond what's on the screen in getting across what the device is and how you use it.
Great, thanks. Glenn or John, any thoughts from you?
Sure, I'll add. For us, it's about how do you minimize the learning curve. And so if you think about getting into a vehicle, and this is, I think this is in general true of any new experience, how intuitive and how easy, how simple is the interface to learn. And so what we found is that, in particular for these initial introductions, keeping things very simple, very easy to learn, as intuitive as possible has been very helpful. It's a different way of interacting than pushing a button or a touch screen. So you have to help people kind of get through that learning curve. And then you have to make the commitment to continue to refine the system over time and recognize that, it's not going to be massively adopted immediately. It's going to take time for the general population to learn, adopt, and then really internalize the use of these new modalities. And so for us, the challenge is how do we make that first step as simple and as rewarding as possible so it's an enjoyable experience for the end consumer.
I think that's absolutely right. The idea that it has to be as intuitive as possible. It has to start simply. The other thing that's critical, obviously, if we want gestural UI to go everywhere, is that there has to be a set of standards. And as much as I'm not a fan of the mouse and keyboard as a UI modality, at least every mouse works the same. At least its interaction with the screen is effectively, uniform, irrespective of whether Logitech makes the mouse or Microsoft makes the operating system or whatever. the ways to get, there's sort of two ways to get to that standardization. One is standards bodies, which we don't have at the moment for UI, let alone gesture. The other is through a kind of benevolent monopoly, I guess we could call it. So if you're Apple and it's 1984, you're the only one who's putting out a kind of mouse and keyboard driven UI. If it's successful, then it goes everywhere. And sitting here, I'm thinking that actually Glenn might have the upper hand here. It might be the ubiquity of automobiles in modern life that is that infection vector that gets everybody to think about it, that teaches everybody a few initial tricks. And as you also said, Glenn, it doesn't have to be everything all at once. If you think about, how the iPhone UI has evolved, when the first version came out, it didn't do very much. It didn't even have cut and copy and paste. Not just because they were, not just because they were, letting out the teachings in bite-sized pieces. I think they didn't know how to make it work yet, but that's okay. You teach people a little, you watch, you learn, you get feedback, as Matt's saying, then you refine and you evolve. And I think that may be the opportunity right here.
Well, John, you stole my thunder there a little bit, because since we're at the Technology and Standards Forum, that was probably going to be my next question about standards. And I will say CTA is a standard setting body, and maybe there's some work here we can explore in the space.
Let's go.
So
Let's do it.
Maybe to dive into this a little bit more, and maybe Matt, I'll start with you. I'd love to get some thoughts on how you choose the gestures that you're using. You talked a little bit about the user experience and the different use case, kind of what goes into that process for if we were to consider some broad standardized set of gestures or applications, kind of where might we even start that discussion?
In terms of how we choose the moment, for me, it's all about exposure to real people and real testing and doing that well. I mean, we've, a few years back, we were a fairly small tech startup, and we began with experimenting with the tech. Particularly when you look at the early days of Leap Motion and Ultra Haptics, the two companies that eventually formed Ultraleap. There's a huge body of work and a whole community of developers experimenting with it. So we had a ton of stuff out there that people were experimenting with, but part of our work has been to try and be more rigorous in how we look at that stuff. So we're really going to try this in a car HMI and a simulator, and we're really going to try this in a public display in a movie theater and put it out there in the real world. So part of our work has been gradually building up that body of understanding and evidence to say, yes, we've tested this with real people, and we've proved that it does actually have benefit and it works. This is an ongoing process, and like the guys have alluded to, there are so many different factors, from ergonomics to lighting to the machine itself. So I don't think we're going to have a short list that we can say always works everywhere anytime soon, but we're getting there, and we're starting to learn which are most robust and which we can apply, and the situations we can apply them in.
So Glenn, maybe I could ask you to jump in. What have you guys learned? I know you've been in vehicles since about 2016. What has been the market acceptance, the perception of the feature, and how's that playing into what your choices are around the gestures you're using?
Yeah, so I would say there have been two significant learnings. The first was that, we were probably a bit overambitious with the number of gestures we thought we could digest as part of that first product launch. And then we realized, well, how hard and how difficult is it to make sure you have the quality and the performance level for each one to really be able to support it. So down selecting to a much smaller, more manageable, much more robust set was one of our first learnings. And the next really was that what we thought would be just a very premium option was only going to be in a very select number of 7 series vehicles, has now migrated across a much broader lineup. And what we've found is that, again, as part of a more advanced multimodal HMI package, gesture is actually thought, hey, this has really been well received. And so for us now, it's about how do I drive the cost of those systems out? If you think about gesture today in the vehicle, it's a standalone product, if you will. How do I integrate that with the existing infrastructure in the vehicle so I'm not paying such a premium for it? And then how do I continue to make it more robust? And I think with with both of those efforts, we'll see it definitely drive to a much broader market.
Thanks. And John, maybe I can ask you to kind of build on that. What are some of the other modalities or UI interfaces that we should be thinking about to kind of wrap gesture for the consumer to make it a full solution?
Well, there's been some allusion to this idea before, but gesture and voice together is almost uniquely powerful because gesture has the capability to localize spatially. I'm pointing at this, I'm pointing at that, now I'm pointing at this. But it's not so good with time, whereas your voice can say that or now. So the combination of localizing space and time is kind of everything that you need. Of course, and you can meld with all sorts of other modalities as well, kind of mid-air haptic feedback, for example, in Matt's case. But I think that the sort of voice plus gesture in the input stream is critically important. I do want to be a little bit cantankerous here and go back to a previous point, because part of the standardization effort has to be the visual feedback as well. It doesn't work if we just say, well, here's the standard gesture set, and then everybody has a different idea of what a menu looks like, or what does the screen do when you point at it? That part is no less important, and we have to get that right as well. I mean, if you look at the difference between what happens on a Linux desktop and a Windows desktop and Mac desktop, there's not much difference. The difference is entirely aesthetic and surface. The inputs and the outputs, the mouse creeping around the screen and the visuals that respond to it are very, very uniform. And we need that same situation to obtain in the gesture case.
Great. So before we turn it over to our live audience Q&A, I'm going to ask you kind of each one more question and kind of want your quick gut reaction, one sentence response. And, what do you think would be required to make gesture interface commonplace in all of our technology? So John, maybe I'll start with you on that one.
A pandemic, maybe? I don't know. A kind of global consciousness opening that recognizes that the junky old interface that we're still stuck with 35 years later isn't really cutting it. The need to solve much, much bigger problems that demands bigger visual spaces and interaction with bigger visual spaces. That latter point sort of suggests, and I'm old-fashioned in the way I think about this stuff, that part of the contributions will actually come not from the consumer side initially, that by working on systems that are domain specific, that might better serve the needs of highly specialized workers in the information space, we're going to learn more than if all we said was, let's build a game, or not that there's anything wrong with games. In fact, video games are the single most fertile ground for new UI thinking and development. But there has to be kind of a contribution from the professional side where the UI is really tested out and works at the limits of its sophistication. And then that can kind of flow down the hill, as it were, into the full world, the full measure of the full world and consumer applications and devices and the rest of it.
Great. Glenn, how about from you?
I think I'll speak to maybe my market. Within automotive, I think it's really two things. One is the continued refinement and making more robust the system so it can do more in a more reliable and a more versatile way. For instance, today, you have to be, in a certain zone in the vehicle. Your hand has to be positioned in a certain spot. Well, you need to make it where the system doesn't care. It can recognize the gesture anywhere in the car, basically, at the ultimate. So I think the systems just have to continue to be made more robust. And then I think as well, in our market, we have to bring the cost of applying the technology down. So the end consumer can acquire the technology at a very reasonable or cost level where they see the value in it. And it's not a premium option. It's just a standard.
All right. And Matt, additional thoughts?
I think John hit on something a moment ago, which is that there'll be certain cases, and it might be unfortunately COVID related in some places, or it might be professionals doing a certain job where this kind of technology has a massive benefit suddenly, where it reassures them and makes them feel safe and hygienic, or where it suddenly makes their job way easier than it was before. And in moments like that, if you've understood their needs and designed it well, you've got something where they're like, oh, I don't want to go back. This is so much better. I think that's where it starts and takes hold. And I would also say, the reason I'm in this job, and I suspect we all have this in common, is that we see the potential for this stuff. I want to live in a future where I point at things and I say a word and the machines around me know what I want and do what I need, and it's effortless and easy. So finding the places where we can do that and where things just get easier and there's a bit of magic like that, that's the future I want to live in, and that's where we're working towards, I think.
Great, I like that. We're all working towards a little bit of magic. That seems like a great place to stop my questions for you all. And with that, we're going to turn over to our audience Q&A.
Great, thank you for all those remarks. I want to switch and ask a quick question here about some of the technology enablers that might help us to have gesture control come into place. So specifically, we received some questions from our audience about what might be some of the problems or what are some of the barriers to getting gesture more broadly adopted. So John, maybe I could start with you on that one.
Sure. We've been chasing this problem and observing from the sidelines and from the front lines for a decade and a half at least, and in the technological space between fidelity on the one hand and extent of tracking volume on the other hand. So for example, the leap motion sensor, and Matt can speak to this probably better than I, has a high degree of fidelity. It can track your fingertips and your hand to a really kind of deliciously fine-grained degree, but throughout a very, very small tracking space. On the other hand, we've formerly had, time of flight and structured light sensors like the Kinect, which has been end of life, that could track over a larger volume, but could only apprehend very gross gestures with very low spatial fidelity. In the early days at Oblong, we conducted all of our work using an optical motion capture system from Vicon. And we were able to track gloves, fingertips that were appropriately instrumented optically to better than 1/10 of a millimeter in X, Y, and Z over a large tracking volume. But the cost was so insane that I can't even speak it on these airwaves. So I think that's the thing that's got to get solved first. How do we track someone freely over a comfortable human scale tracking volume, but with enough fidelity to tell the difference between this gesture, that gesture, a hand in pose A, pose B, pose C. That's the thing that I think we're all waiting for.
Thanks, John. So Matt, maybe I'll cue you up to jump in there since we referenced Leap Motion's work.
Sure. I think in terms of problems to adoption, for me, from my point of view, it's and something we alluded to in the talk, it's about people walking up to these machines and knowing what to do with them. I talked about the ongoing research to try and strive for the most natural, intuitive thing we can get for. That's the goal. That's the potential we all see with this. But like we said, it's new stuff, and it's fair to say there are limitations. We're dealing with a certain volume. We can track them. There can be issues in occlusion when hands get too close to one another. You have to make sure the camera's mounted in a good place. And, as we look at different use cases in the world, there are limitations about where we can put that and the kind of gestures we can recognize and things like that. So I think you're dealing with the limits of, all those kind of real world limitations of the hardware you've got and cost, etc. And then, of course, this whole new mode of interaction that's new to people and doing everything you can to try and ease them into this new way of doing stuff.
Great, thanks, Matt. Glenn, any thoughts on your end you'd like to add?
Yeah, specific to automotive, I'd say there's three things. The first is cost. How do we drive the cost of the system down so that it can be really broadly applied, either as a standalone feature or working in conjunction with more advanced HMI options? But cost is a huge element of that. How do you make this a very low-cost option to adopt and widely deploy? And then the next is just the robustness of the system so that it can be used in a variety of, not in a very specific or a limited way, but it can be used anywhere in the front of the car or the back of the car. and for a number of different types of functions. And so I think as we do those two things, what will happen naturally is you get more and more exposure, and then it will become a natural part of the overall HMI. Touch, physical touch, voice, eye gaze, as well as gesture.
Great. And so it's great, Glenn, that you just mentioned voice, because we've actually gotten a lot of questions and comments from our audience on kind of how will voice and gesture coexist or interact? Is gesture maybe a replacement for voice, or is it kind of increasing the contextual use of voice recognition technology? So Glenn, I know we touched on this a little bit earlier, but Glenn, do you want to add any more thoughts to that since you just started with voice?
Yeah, I'll maybe address the first question, or the question about is gesture a replacement for voice? And maybe in some very limited use cases, you can use gesture as an alternative to voice, but we tend to think of them as modalities that work together, and so that build off each other, or are able to combine and leverage the strength of gesture versus the strength of voice. And so each modality has strengths and weaknesses, and the idea is by combining those, I get a much more reliable HMI. So I can point at something and say, please turn that on. Please turn on the infotainment system. I can point at something on the road and ask a question. And it's that combination of the modalities that actually gives you a richer and a much deeper HMI that ideally is a better consumer experience.
Great. And then maybe before I turn to our other panelists to add some more thoughts, I might also add the question around eye tracking and how that might play into it. We've also received some inquiries from our audience on that. So maybe, Matt, I could turn to you and add eye tracking to voice as some of our additional modalities to discuss.
Sure. I think I mentioned when I was talking about what we do in VR that we are generally dealing with a very limited number of gestures. The guys have also mentioned this. It's small numbers. In many of the applications I'm working on, one or two is enough. And then you may get into situations where you need to do more things, but you can't just have a whole library of gestures that you wave your hands about with. And so these complementary modalities may be a way to do that. So to take an example, let's say I'm in VR and I'm an architect, let's say. Using my hands to design a building or rearrange a landscape makes perfect sense. It's a very natural and intuitive thing to do. But I'm going to run out of gestures pretty quick. So if I can use my voice, or if I can use my eyes to tell the system there are other things I want to do, give me a different tool in my hand, show me what happens when the sun's coming from another direction, these kind of things. So I'm definitely finding as we work with it more that there are just some wonderful moments where hand tracking and gestures makes perfect sense. But if that's the only thing you're using, you start to have to do a lot of workarounds to fit in all the functionality. So I can see the real potential of combining these things to do that.
Great. And then, John, maybe I could shift over to you, and I'm going to just add another element onto the question here, because we received another question from the audience is, when we think about the number of gestures, as Matt was just alluding to, is there kind of a maximum number of gestures we might be able to have, or is it an infinite number, or should we think about a succinct number of gestures to be used and then add these other modalities as points along the way? So just adding on to this question we're building here.
Oh, thanks, Carrie. So we'll start with the last one and back up. I think, of course, an infinite set of gestures is intractable. Even a large set of gestures isn't really going to work, except in the most kind of domain-specific and work-intensive environments where it's worth learning a large set of gestures. And again, we have to look to video games. I mean, the things that people can accomplish in a video game context with what is, at the end of the day, a very simple controller. It's got, 4 buttons on the left, 4 buttons on the right, some joysticks, is incredible, 6 degree of navigation and the rest of it. So when people are properly motivated, they can learn a lot. But let's assume that won't be the case for normal everyday use. What we end up with then is, I think, a basic set of gestures that's 3 to 6 in count total. And there we get to the importance of not only standardization, but the kind of visual part of the UI, the feedback that you get as you're making these gestures. to back up into the previous question, of course, I agree with Matt and Glenn about the importance of finding complementary input and output modalities. But there's something more fundamental going on here, which is partly due to an American psychology that says something always has to win, something has to displace or disrupt or supplant something else. And that's amplified by an accident of history, which is that we've had this keyboard and mouse thing dominant for 35 years. And that's not because it's very great at all. I mean, I guess to its credit, it's just barely good enough to have served us for 35 years. But it's important to recognize that that's an artificial situation. It's artificial just to have one modality. You go into the kitchen, you open a drawer, there's a lot of stuff, and you're able to deal with it. You don't get confused. You don't try to cut a steak with an ice cream scoop, like you know how to use the right tool for the right task. So I think the future is going to be characterized by a multiplicity of input modalities and interaction modalities. And really, this gets straight to the heart of the issue and the challenge and the opportunity and the excitement, which is designing a new kind of user interface, full loop UI that includes the graphics on the other end, the stuff you see, that makes sense of using multiple input modalities, sometimes simultaneously, voice plus eye tracking plus gesture, or a mouse and keyboard, or mouse and keyboard and touch and eye tracking. It all has to live in the same space. And for us at Oblong, the key to that space is to look to the real world. How does the real world work? How do people interact with each other? How does it work when you can see that you've lost eye contact with someone, even though they're still talking to you and apparently listening? All of those things are cues, and we need to build that same sensibility into our UIs.
Great. Thanks so much. And so before I shift to a slightly different topic, I want to just quickly jump back and see Glenn or Matt, since I expanded the question a lot along the way, if there's anything else you wanted to add, you know, on eye tracking, and then just kind of the context and set of gestures.
Yeah, this is Glenn. I could just add eye tracking for us, and it's really eye tracking along with, you know, the driver, in our case, the driver's head position and head pose. It just provides more contextual information that helps you understand, you know, what's happening at the time of the command or at the time of issuing the command, and which is always good, because with any of these systems, the reliability of the interface is really critical to the customer experience. If the system is not reliable, it's a very bad experience. And so, to the extent that you can take advantage of other information, like where the person's looking or their current state, that helps you determine more accurately what the intent is, and that end result is a better experience. So we're excited about the work that we're doing with eye gaze and head position tracking.
Great. And Matt, any last thoughts from you on that topic before I bring up a different one?
I think just to say again, when we've worked in an XR environment, you know, I can certainly see eye tracking in that environment, particularly where somebody's got 360-degree movement and they could be looking all around them. You know, there's a case where knowing where they're looking could provide you a ton of new contextual information. And whereas if I'm standing in front of an ATM, you know, that may be less effective. You know, there's less screen I may be looking at, etc. So yeah, I think that's the case for us. It's that the extra information that we can use, and that may allow us to change the experience, give them more of what they need, because we just have more context.
Great, thanks. So I wanted to shift a little bit and ask another question that we received about some of the kind of inclusive design elements for gesture control, and ask each of you, and Glenn, I might start with you because you talked a little bit in your presentation about making a circle. What type of considerations have been given in your gestures to maybe those that might not have fine motor control, either due to disability or age or some other reason, and how do we kind of make sure that this type of work is inclusive for all folks to be able to use it?
Yeah, I think that's a great question, because, you know, as we develop these interfaces, it has to be usable by the full population and broadly applicable. And so we really do two things. One that we talked about was really simplify and really use gestures that, generally speaking, can be easily applied or utilized by the vast majority of people. And so it's that simplification of the number and the sophistication of the gesture. Just make it as easy as possible so that, that the system has an easier time recognizing the intent of the gesture. And then it's about training. And so you have to, as you train these systems to recognize those gestures, you have to have a training library and build a library that encompasses every potential use case. And that's the use case that surrounds the individual's physical characteristics as well as the environment. So lighting, conditions, things like this. And then, and that's really where you spend quite a bit of the energy and time, is in that training and then verifications phase, making sure it works across that full range of individuals that want to use the system. And that takes quite an effort, which is, again, why we tend to simplify the number of gestures that we use in our library.
Great. Matt, any thoughts from you on that?
Yeah, and I think in terms of accessibility, it's absolutely. And I think this has the potential. I think about a touchscreen in a public environment and the height of it. And, I've seen examples of machines where there is an accessible mode you can switch it into, and it's definitely the poorer cousin to the main thing. It can sometimes come across as an afterthought. And I think there may well be cases where knowing where people's hands are and knowing what they're doing, can enable everyone to have the same quality experience. I will say, like anything we're doing with this work, it's all ongoing and we're learning. But I think it's definitely, I've certainly found over the years that the wider range of people you consider, the wider range of people you do research with and you test with, the better. And I do believe that it's a lot of extra work, as the guys were saying, but you end up with a better experience for everybody. If you put in the extra time and effort to make sure that wider range of people can use it, I don't think anybody loses out in the end. You just got to put in the work.
Great, thanks. And John, I'll see if you want to add anything to that. And then I've got one last question for our panelists here today.
Fantastic. I think there's two pieces. One Glenn already alluded to, and that's the idea of kind of adaptive sensing, if you will, on the part of the system. Something that looks to you and me like a circle, or something that looks like a flattened circle or a jagged circle, and therefore looks inappropriate, may be much closer in an appropriately trained machine vision space. So it's possible to use machine learning to kind of do adaptive sensing per user, so that people who have different musculoskeletal arrangements, and it's amazing once you start studying it, how much people's hand anatomies differ, but also people who may be afflicted with neurodegenerative diseases. So you can conform all of those styles, to give it a not quite appropriate word, and get the same input and lead to the same output. It may also be possible to deploy additional sensing modalities that aren't obvious. So if we're able to gain access to certain nervous system events that are upstream from places where afflictions may actually end up manifesting, then the intent of the gesture may be clear. The second piece is ultimately more important, however, and that is, again, in this idea of a UI universe that admits a multiplicity of modes. So if everything is gesture, then things are not going to be very useful for people who have a hard time gesturing. But if we have systems that by default, and also by good design, are universally admissive of not only gesture, but voice, eye tracking, and a bunch of other modalities. And if we design the systems to allow overlap, so that there's not just one way to do anything, there are probably multiple equally valid and equally efficient ways, then there's always a way for any particular user to find her path through the UI.
Great. Thanks so much for all that to think about. So with our last minute here today, I want to ask maybe a little self-serving of a question, but each of our panelists, that if we talked a little bit about standards, and we got a lot of questions about standards in the chat. if there was one thing a standard setting organization like CTA, for example, should look to tackle, where would you recommend that we start? So Matt, maybe I'll start with you.
I've just sort of been thinking about an interesting thing that's come up with us, and that, you know, we make the hardware that we make, and we work with a lot of different customers to help them kind of craft these experiences. But ultimately, it's not people like me who are implementing these UIs and these gestures, not the end stuff that goes out into the world. I'm kind of just helping them learn what to do with the tech and how to do it well. And there are, you know, I'm meeting people who don't have any experience working with this tech or designing systems that work in 3D or recognize hands. So, you know, there are developers and graphic designers and all manner of people out there who are completely new to this. And when they're trying to understand, you know, I'm trying to communicate interactions and gestures to them, and it's a whole new language, and it's you know, it can be a very difficult thing to get across. The shape of the hand, the motion, the UI, and all these things together. So I would say I think that there are all those people that are going to suddenly be working with this stuff day to day who don't necessarily work in the kind of companies that we do. Giving them a sort of a standard terminology, standard visual references, really easy to pick up stuff, and good tools too, you know, good software tools that will enable them to use this stuff without putting in too much hard work. That would be my recommendation, I'd say.
All right, so we're winding up here. So I'm going to say, Glenn, any quick remarks from you, and then we'll shift to John to wrap up our session.
Sure, I think it's a great question around standards. When you think about standards, where they're really valuable, when they're broadly applied, like vehicle safety standards, so that everybody that experiences them understands them immediately. So I think when you think about gesture, it's a very nascent technology still. It's been around a while, but it's still relatively nascent in terms of its application. So I think one of the best things to do, it's about education. It's about understanding and bringing together the community of developers that are working in that space, both on the tech as well as the application side, so that you start forming kind of a critical mass of thinking around, should there be standards, and if so, where? And so when I think about gesture, I kind of think of us in that phase of the standards creation spectrum. And so I think forums like today are a great example of exactly that. It's bringing together people and then having a great discussion around these things.
Great, thanks, Glenn. And a final word from you, John?
How can CTA as a standards body help out with gestural standards? That's the question. Let's do it.
Yeah.
You have our emails. Let's bring us together, not just us, but let's bring together everybody who's working in the field. The time is now, right? The time, once everything starts to get ossified and there are monopolies in place, is too late. Let's do it now. And I think it's a great opportunity. The people are passionate about it. You can tell I don't care very much about this kind of thing, but let's get together the folks who are putting their lives, their livelihoods, their energy into this stuff. And, you know, let's make it as rich and promising, as rich as it is promising today. And that the idea of community that Glenn nominates is exactly the thing that doesn't exist now and needs to. And I think CTA is the perfect body to do it.
Well, I'm not sure that we could have wrapped that up in any better fashion. So thank you so much to all of our speakers for being here today and joining us and being a part of this really exciting dialogue. And now, as we prepare to close our first virtual technology and standards forum, I'd like to introduce Brian Markwalter, our Senior Vice President of Research and Standards at CTA. And Brian's going to provide us with an overview of the week's activities. So welcome, Brian.
Thank you, Carrie. Can you hear me okay? So that was a fantastic session. I'm really impressed, and good afternoon, everyone. I am Brian Markwalter, Senior Vice President, Research and Standards at CTA. I'm glad that you are able to join us this week as we have conducted and now wrapped up our first virtual Technology and Standards Forum. It was a great week. We held 19 standards meetings and hosted 5 panels on a variety of topics with over 540 participants joining us this week. While we missed being with you all in person, we are thrilled at the amount of work that we were able to accomplish in this virtual environment. Together, we continue to advance critical work on digital therapeutics, AI, cybersecurity, and XR. We have participants join us from around the globe, including Europe, Korea, and Australia. We opened the week with CTA's own Leslie Rohrbaugh and Steve Koenig exploring the impact of COVID-19 on the technology industry. CTA continues to monitor the impact of COVID-19 on the technology sector through research available to members. Steve and Leslie drew upon the research you see listed here, 6 studies the CTA market research team has conducted since March to quantify changes since the pandemic started. As a reminder, we have more research in the pipeline, including a second wave member impact study coming out soon. We learned that COVID-19 has shifted consumer behaviors, which will likely result in new habits forming that will last beyond the health crisis. However, this crisis also creates opportunity. Technology is providing answers and solutions. We expect more solutions will come. Even though our patterns have shifted, we expect the demand for technology to remain intact and help lead the path to recovery. We also explored how artificial intelligence is going beyond the buzz in healthcare and is already in use. Nicola from Ginger explained how AI can provide better access to mental health care. Data-driven AI can help determine who needs support and what type of support they need. Maya Health showed how its AI system augments the way clinical teams care for patients beyond the hospital. Telehealth is becoming more mainstream with COVID-19, and AI and machine learning can transform virtual care. Intel discussed how their Health and Life Sciences division is exploring ways AI can help physicians and researchers by developing new insights based on complex and varied data. Healthcare is also being transformed by XR and robotics. We heard from Pillow Health, Eris MD, and Ava Robotics. They're using these technologies to improve healthcare outcomes. XR and robotics can transform healthcare by acting as a healthcare hub in the home, connecting devices, and making video connections with physicians, caregivers, and loved ones, as well as navigating spaces with ease. Use cases include virtual visits, elder care, remote site visits, team collaboration, as well as manufacturing. Yesterday, we discussed the business of smart energy as a continuation from work that launched at our fall forum in 2019. Our speakers from Packetized Energy, Amazon Lab 126, SunSpec Alliance, and CTA discussed the existing standards for smart home devices, distributed energy resources, and energy cloud aggregators, and future standards needs in communication and interoperability. Most of you are here just now and got to experience our great panel on the use of gesture control firsthand. Gesture has been linked to gaming applications, and as we heard, Minority Report, in the past, but as we've just learned, there are many areas that are beginning to apply gesture control features in the use of vehicles, AR, VR, retail, and robotics. Given that gesture control is touchless, there's an obvious linkage with how gesture control can bridge comfort levels of consumers returning to their communities. We are grateful for each of our speakers that gave of their time, shared their expertise, and worked with the CTA staff team as we pulled together this event. If you missed any of these exciting sessions, you can replay them by visiting cta.tech and clicking on events. And of course, I'd be remiss not to talk about standards. That's the reason TNS Forum began more than 2 decades ago. Get a feel for the breadth of topics covered by CTA standards from the list of groups shown here that met this week. We covered everything from traditional audio and video standards to the latest AI, cybersecurity, and robotics projects. I'll spare you a recap of these 19 meetings. Many of our regular standards participants work with CTA to develop standards that help products work together, help consumers understand product performance, and help the industry by establishing basic guidelines for product functionality. For our new guests, we invite you to join this process. In 2019, CTA published 41 standards, including 21 newer revised standards covering the variety of technologies we've discussed here this week. Throughout the week, we've experienced a new office environment, including visits from our new coworkers, like these pets that we see here. And as always, we've had a few issues with the mute button, It's the new normal we're living in, but I am inspired by the way our industry has risen to the challenge and continues to work together in standards development to address key issues. CTA, we have responded to our members' needs and have held 6 webinars over the past 3 weeks, addressing a range of topics, including how to manage business continuity, how companies can show empathy to employees, provide small business assistance, and using tech to address isolation. We're continuing to bring you information critical to your business in the new normal. If you haven't already, I strongly encourage you to visit the CTA member resource page that is updated and refreshed regularly with information, including the weekly CTA tech use and purchase tracker, which monitors consumer usage and purchase across technology categories during the pandemic. As we look to the future, and specifically CES 2021, we're working to create an action plan that incorporates best practices for a healthy and safe show, and will provide regular updates on CES.tech. We're working to expand the aisles for added distance between attendees and extending our digital platform. This is not just a one-time approach. We will continue to work with you all to innovate and expand the reach of CES 2021, 2022, and beyond. We know that we'll be together again, and we look forward to that time. CTA is monitoring federal and state-specific recommended guidelines related to travel restrictions and social distancing requirements. At this time, we're asking all of you to save the date for Fall Forum, September 21st through 24th. We will share information related to whether Fall Forum will be virtual or face-to-face as soon as possible. In closing, I want to thank you for attending, thank our speakers and committed volunteer leaders for participating, and thank the CTA staff who made TNS Forum happen. Stay safe, stay healthy, and if there's anything CTA can do to help, please do not hesitate to ask. Bye.